Today in this video I am going to discuss arithmetic progression and some of its important properties. So let's start with definition. Arithmetic progression Precisely what is progression? Progression is a sequence which follows a particular pattern, a sequence of numbers or letters or some expressions which follow a particular pattern is called a progression. And when it is called an arithmetic progression, so let's define arithmetic progression. A progression is said to be an arithmetic progression if the difference between any two consecutive terms is always constant. Or in other words, we can say a progression is said to be an arithmetic progression if every term is obtained by adding a constant number or constant term to the previous term. A progression is said to be an arithmetic progression which is written in abbreviation as AP, arithmetic progression. A progression is said to be an arithmetic progression if the difference between every two consecutive terms is constant. Or in other words, we may define it as a progression is said to be an arithmetic progression that is AP if every term may be obtained by adding a constant term in the previous term. For example, 2, 4, 6, 8 and so on. So if we consider the first language of arithmetic progression, so we say the progression is said to be an arithmetic progression if difference between every two consecutive terms is constant. What are consecutive terms? Consecutive terms means the terms without gap. That means these are two consecutive terms. 2 and 4 are two consecutive terms. 4 and 6 are two consecutive terms. 6 and 8 are consecutive terms. But if we talk about 4 and 8 are not consecutive because there is 6 between them. So the terms between which there is no other term, those terms are said to be consecutive terms. So according to the first language, if we take the difference of every two consecutive terms, the difference is always constant. So simply if we subtract 2 from 4, we get 2. If we subtract 4 from 6, we get 2. If we subtract 6 from 8, we get 2. So in this way we can say that the difference between every two consecutive terms is constant, and that is 2. So such types of progressions are called arithmetic progressions. If we consider the second language, a progression is said to be arithmetic progression if every term may be obtained by adding a constant term in the previous term. For example, if we want to get this term, we have to add 2 in this. In the previous term, if we add 2, we get 4. If we add previous term to 6, 2 in this, we get 6. If we add 2 in this, we get 8. So adding 2 in every term, we get the next term, or we may say that every term is obtained by adding 2 to the previous term. So in any way you may define it. Now let's talk about nth term of an AP. So let A is the first term of an AP and D is the common difference of the AP. What is the common difference? The constant difference between every two consecutive terms, that is called common difference. So if an AP has A as the first term and D as the common difference, so we know that every term is obtained by adding this common difference in the previous term. So if we want to find the next term, so we have to add D to A. So we have A plus D. And if we add D in this, we get the next term. So A plus 2D. If we add D in this, we get the next term. A plus 3D. And so on. So this is the first term, this is the second term, this is third term, and this is fourth term. So if we write it as first term, if we denote by A1, that is A. And if we denote second term by A2, that is A plus D. If we denote third term by A3 is equal to, that is A plus 2D. So if we denote fourth term by A4, that is A4 is equal to A plus 3D, and so on. Now, the first term A may also be written as A plus 1 minus 1 into D. As you know, 1 minus 1 is 0 and 0 into D is 0. 0 plus A is 8. In the same way, A plus D may be written as A plus 2 minus 1 into D. As you know, 2 minus 1 is 1, 1 into D is D, so we get the same A plus D. A plus 2D may be written as A plus 3 minus 1 into D, because 3 minus 1 is 2 and there is 2D, so A plus 2D, we get the same. A plus 3D may be written as A plus 4 minus 1 into D. So after writing these terms in this fashion, we observe the pattern and we generalize the term. We have in the first term we get the coefficient of D as 1 minus 1. In the second term, the coefficient of D is 2 minus 1. In third term, the coefficient is 3 minus 1. in the fourth term the coefficient of d is 4 minus 1. So we observe that every term has a plus constant, and in the next term in the bracket the coefficient of d is the order of the term minus 1. The order of the term is 1, so there is 1 minus 1. Here order of the term is 2, there is 2 minus 1. Here order of the term is 3, so the coefficient is 3 minus 1. Order of the term is 4, the coefficient is 4 minus 1. That means this number is exactly the same as the order of the term. So in this way we may take this analogy and we may write its nth term. So nth term must have a plus as it is, and here it must have n minus 1 as it is into d. So an, that is the nth term of an AP, is equal to a plus n minus 1 into d. For example, the question is find 21st term of the AP 1, 6, 11, 11, 16 and so on. So simply if we observe it in an AP, if it is not mentioned in the question itself, so 6 minus 1 is 5, 11 minus 6 is 5, 16 minus 11 is 5. So the difference between every two consecutive terms is constant, so that is an AP. So what is the first term in this AP? That is 1, and the common difference, as I have told, that is 5, and we have to find 21st term. That means n is equal to 21 and we have to find out an. So as we know, the nth term of an AP is equal to an is equal to a plus n minus 1 into d. In this formula there are 4 symbols, 4 unknowns, that is an, and d. an, and d. Out of these 4 unknowns, if we know 3, the fourth one we may find out. So sometime in the examinations these 3 are given as in this question, a, d and n are given and we have to find out an. Sometimes an is given, a is given, d is given, and we have to find out n. Sometimes an, n is given and we need to find out d. So in this question we have a, d and n and we have to find out an. So simply we have to substitute these values in the formula. A is 1 plus n is 21, so 21 minus 1 into d, d is 5. So 1 plus 21 minus 1, 20, 20 multiplied by 5, that is 1 plus 100, that is equal to 101. Now the next example is which term of the AP 4, 9, 14 and so on is 254. So here the first term is 4, common difference is equal to 5. As you see, 9 minus 4 is 5, 14 minus 9 is 5. So common difference is 5. And the question is which term is 254 in this AP. That means the term is given and we need to find out the order of the term, whether it is 20th term or 21st term or 22nd term. That means we have to find out n, where an is given. So the term is considered as an 254 and we have to find out n, order of the term. So we know an is equal to a plus n minus 1 into d. Out of these 4 identities we have 3, that is a, d and an n is unknown, so we have to find out n. So substitute an as 254 is equal to a is 4 plus n we have to find out, so write n minus 1 as it is, and d is equal to 5. Now transpose 4 to left hand side, we have 254 minus 4 is equal to n minus 1 into 5. 254 minus 4 is 250 is equal to 5n minus 5, and transposing 5 to this side, it will divide 250, and on the right hand side we are left with n minus 1. 5 will cancel 25 5 times, so it will divide 250 50 times. 5 5 is 25, 0 as it is. So n minus 1 is equal to 50. Transposing 1 to that side, it becomes positive, so we have n is equal to 50 plus 1 and n is equal to 51. Now we have to talk about the sum of n terms of an AP. So let a plus d, a plus 2d, a plus 3d and so on to infinity is an AP, arbitrary. So here we know a1 is equal to a, and a2 is equal to a plus d, a3 is equal to a plus 2d, and a4 is equal to a plus 3d and so on to an is equal to a plus n minus 1 into d. Now here, what is Sn? Sum of first n terms, sum of n terms of an AP, that means sum of first n terms. So first n terms means a1, a2, a3 and so on to an. So if we get the total, if we add these equations, we get on the left hand side a1 plus a2 plus a3 plus so on to an. And on the right hand side we get a plus d plus a plus 2d plus so on to a plus n minus 1 into d. Or you simply write it as, we better write it at the vertically. So if we see a plus a plus a plus a plus, these a are added n times. If we add all these three equations, there are n equations, and so this term, which is constant in every term, it is added n times. So if a is repeatedly added n times, so this answer must be, sum must be na. So the total of a plus a plus a plus a n times, that is na. As simply you, if a is added 2 times, you will get 2a. If a is added 3 times, you will get 3a. If a is added 4 times, you will get 4a. In the same way, if a is added n times, you will get na. Plus the second terms are added together, that is d plus 2d plus 3d plus so on to n minus 1 into d. d plus 2d plus 3d plus so on to n minus 1 into d. a1 plus a2 plus a3 and so on to an, that is a sum of first n terms. It is denoted by Sn. On the right hand side, Na as it is. If we take d common out of these terms, because obviously d is common, so we take d common. In the bracket we have 1 plus 2 plus 3 plus so on to n minus 1. So we have na plus d into 1 plus 2 plus 3 and so on to n minus 1. This is the sum of first n minus 1 natural number. The first n minus 1 natural number means from 1 to n minus 1. So the sum of n minus 1 natural number from 1, 2, 3 and so on to up to n minus 1, it is denoted by sigma n minus 1. Sigma n minus 1 means sum of all the natural numbers from 1 to n minus 1. And the formula for sigma n is n plus 1 upon 2. So if we replace n by n minus 1 in this formula, we have sigma n minus 1 is equal to n minus 1 bracket n minus 1 plus 1 upon 2. We have substituted n is equal to minus 1, so this is n minus 1 and here n minus 1 plus 1. This minus 1 and plus 1 is cancelled and we get sigma n minus 1 is equal to, here n is left, so write it first, and the bracket n minus 1 upon 2. So we get sigma n minus 1 is equal to n minus 1 upon 2. So if we write it as na plus d and sigma n minus 1, if we write the value of sigma n minus 1 as n minus 1 upon 2. So you see Sn is equal to, out of these two terms what is common? The common is n. So we take n common, in the bracket we have a plus d n minus 1 upon 2. So that is equal to n, and in the bracket if we take 2 LCM, so 2 will multiply a, in the numerator we have 2a plus, and here we have n minus 1 into d, here d into n minus 1 in the same way. Anyway, you may write it. And now because this is common denominator, this may also be written outside under this n. So Sn is written as n upon 2 within bracket 2a plus n minus 1 into d. So this is the derivation of the formula sum of n terms. Sn is equal to n upon 2 2a plus n minus 1 into d. One thing must also be clear. As you see, a is the first term and a plus d is the second term, a plus 2d is the third term, plus so on to a plus n minus 1 into d is the nth term. This is the sum of first n terms of an AP, which is denoted by Sn, you know well. And we have proved that Sn is equal to n upon 2 2a plus n minus 1 into d. So Sn is equal to n upon 2, and here we may break this 2 as a plus n minus 1 into d as it is. You see, the first term is a and the second term is, and the last term is a plus n minus 1 into d, which is the same, a plus n minus 1 into d. So this is the last term in our progression and this is the first term. So this formula may also be written as Sn is equal to n upon 2 a plus L for last term. So we may write this formula as Sn is equal to n upon 2 a plus L, and this is only used when we know the number of the terms in the sequence and first term and the last term. Now for example, we have to find the sum of first 10 terms of an AP 41, 36, 31 and so on. So first we have to mention the first term, let it be a. A is the first term, first term is denoted by a generally. So a is equal to 41 and the common difference is generally denoted by small d, which is always the difference of any two consecutive terms, and generally we find by subtracting the first term from the second term. So second term minus first term, that is 36 minus 41, that is equal to minus 5. So minus 5 is the common difference. So now we have to find out the sum of 10 terms of this AP. So n is equal to number of terms up to which we have to find out sum, and Sn, that is the sum which is required. So Sn is question mark. So Sn is equal to n upon 2, 2a plus n minus 1 into d. Here substitute n is 10, 10 upon 2, 2 into a is 41, 41 plus n is 10, so 10 minus 1 into d, d is minus 5. So 2 will cancel 10 5 times. We have 5 in the bracket. 2 1s are 2, 2 4s are 8, so 82. And this minus into plus becomes minus, and 10 minus 1 is 9 into 5. So simply we have 5 into 82 minus 9 5s are 45, and we have 5 into 5 from 12, 7, and 7 are left over there. 4 from 7, 3, 37 we have. So multiply by 5. 5 7s are 35, 5 3 carry over number, 5 3 is 15 and 3 18, so 8. So 185 is the sum of first 10 terms. So simply we may also write it as 10 because n is 10. So sum of first 10 terms of the given AP is 185. Now here I would like to discuss a very important point. In some of the language problems, only 3 numbers in AP are considered. So in that case, we always assume a specific set of numbers. Those numbers are called recommended assumptions. Recommended assumptions for 3 terms in AP. So if we see in the language problems, only 3 numbers in AP are considered and 2 different conditions are given in the problem. So we always assume the numbers as a minus d, a plus d. As you see, if we subtract a minus d from a, we have d. If we subtract a from a plus d, we have d. So obviously these 3 numbers, 3 arbitrary numbers we may say, are in AP. So in this type of questions, as I have given, as I have taken this example, if the sum of 3 numbers in AP is 27 and their product is 648, find the numbers. So see, if the sum of 3 numbers in AP, only 3 numbers in AP are discussed and 2 conditions are given. One is the sum of 3 numbers and other is the product of 3 numbers. In that particular situation, we always consider these 3 arbitrary numbers as numbers in AP. So proceeding, let this be the numbers, So as language, according to the language of the problem, the sum of the 3 numbers is 27. So we have assumed these 3 numbers. So sum of these 3 numbers is a minus d plus a plus d. A plus d is equal to 27. So you see the sum of these 3 numbers, a minus d plus d is equal to 27. and here minus d and plus d is cancelled, and only these 3a are left. All the 3a's are positive, so should be added. We get 3a is equal to 27. So a is equal to 27 upon 3, and 3 9s are 27. So simply a is equal to 9. Next condition is their product is 648. So product of these three numbers, that is a minus d into a plus d, is equal to 648. Now substituting the value a is equal to 9 in this equation, we have 9 minus d into 9 into 9 plus d is equal to 648. So we may write it as 9 as constant coefficient, and 9 minus d, 9 plus d, that means we may use the formula a plus b, a minus b is equal to a square minus b square. So we may write it as 9 square, that is 81 minus d square, is equal to 648. Now transposing 9 to that side, 9 will divide the right hand side. 81 minus d square is equal to 648 divided by 9. So divided by 9, 9 sevens are 63, 18 are left, 9 twos are 18. So 72 times it will divide. And now 81 minus d square is equal to 72. So transposing 81 to that side, we have minus d square on the left hand side, and on the right hand side we have 72, which was already there, and we have transposed 81 to right hand side, it becomes negative. So minus d square is equal to 72 minus 81 is equal to minus 9, because negatives are more than positives. So if we cancel 72 positives from 81 negatives, only 9 negatives are left. So these two minus are cancelled from both the sides. We have d square is equal to 9 and d is equal to plus minus 3. If we taking square root, we get d is equal to plus minus 3. So two conditions, either a is equal to 9 and d is equal to plus 3. So the numbers which were assumed as a minus d, a and a plus d, a minus d is equal to 9 minus 3 is equal to 6, and the next number was a is equal to 9 itself, and the next one is a plus d, which is equal to 9 plus 3, which is equal to 12. So a minus d is equal to 6, a is equal to 9, and a plus d is equal to 12. So the required numbers are 6, 9, 12, or a is equal to 9 and d is equal to minus 3. So the sequence will change simply. We get the first number as 12, second number is 9, and the third number is 6. So ultimately the three required numbers are 6, 9, 12 or 12, 9, 6. So this is the way to solve this type of language problems in which only three numbers in AP are considered. So always remember these three numbers should be assumed. This assumption makes your calculations very simple. And so in the same way as I have given the important point for the three terms in AP, we always assumed some specific terms in a particular fashion, which is called recommended assumption for three numbers in AP. In the same way, the recommended assumption for four terms in AP are recommended assumption for assumptions for 4 terms is a minus 3d, a minus d, a plus d and a plus 3d. And the recommended assumption for 5 terms, if 2 different conditions are given for 5 terms, we consider a minus 2d, a minus d, a plus d, a plus 2d. So this is all about AP, though I may not explain each and every type of question because this is a topic which has a large number of sums, different kinds of sums. The variety is very vast. So I may not give example of each kind of question based on arithmetic progression because it requires several hours. So I have given only the important points of arithmetic progression in this video so that the duration of the video must not exceed more than an hour or half an hour. So I request all my viewers, if you have any specific problem related to arithmetic progression, you may write in my comment section. I will try my best to give the proper solution through any means. You may provide me your WhatsApp number or email ID. I will always try to answer or fulfill your requirement or query. Thank you very much once again. Wassalam.